Polynomial remainder theorem states that if we have f of x, some polynomial, and we divide it by a linear factor, x minus a, and that has a remainder r, then the value of the function at a is equal to r. That's not very intuitive at the beginning, so let's figure out why that might be. So let's say we have a polynomial, and we divide it by x minus a. I know from the last video that I can rewrite that as some sort of polynomial, I'll call it q of x, plus whatever the remainder is divided by x minus a. So if I multiply the entire equation through by x minus a, what I'm left with is f of x equals q of x, which is whatever my polynomial part was, times x minus a, plus the remainder. If I substitute a in for f, notice that I will have q of a, and then I will have a minus a. Notice that's 0, so this whole part becomes 0, plus whatever the remainder is. So, in this case, f of a is just going to equal to the remainder. If I take this f of x and I divide it by x minus 4, I'm going to do a little synthetic division. So I have 24, 5, 20, 36, and then 36 times 4 is 120 plus 24, so that's 144. So I get 140. If I rewrite this, so f of x divided by x minus 4, I could write that as 6x squared plus 5x plus 36 plus 140 over x minus 4. I could then rewrite that to get f of x all by itself. So f of x, then I'm going to multiply x minus 4 all the way over. So I have 6x squared plus 5x plus 36 times x minus 4 plus 140. So if we take a note that if I substitute 4 into this equation, notice that this is going to be something that is probably a big number, but 4 minus 4 is 0. So I end up with 0 plus 140. So f of 4 has to be 140. Note that was the remainder. So if I look at the synthetic substitution part of this, basically all I have to do is do synthetic division or synthetic substitution, and then whatever my remainder is the answer. So if I take problem 1 and I do all of the work, I'm going to end up with 140. The reason I know that is I just took this exact problem and I'm figuring out what would happen if I substitute 4 in. So f of 4 equals 140. Notice that that ends up being a really simple way of finding values by substituting them into equations, that if I tried to do this without a calculator, without knowing synthetic substitution, this would be pretty hard. But since I know that the remainder of the division of the polynomial ends up being the answer, it's not nearly as bad. Problem 2. So now I just know that if I substitute negative 4 in, if I divide by x plus 4, basically, whatever the remainder is ends up being my answer. So I'm going to do synthetic substitution. And I end up with 108 minus 18 gives me 90. So in this case, I know that f of negative 4 equals 90. Problem 3. 2, negative 3, negative 11, 6, and I want to substitute in negative 7. 2, negative 14 makes negative 17. Negative 17 times negative 7 gives me 70 plus 49. So that's 119. 108. 108 times 7 gives me 756. So that's negative 756. And then I add these together and I get negative 750. So as a result, I know that f of negative 7 equals negative 750. Finally, problem 4, we're just going to substitute in 20. I get 1, negative 6. Oh, my fault. I'm missing a 0. 1, 0, negative 1, negative 6. I do a little substitution. So 399 times 20 is, that's going to be 400 times 20, which would be 8,000, then minus 20. So that's 7,980. So I end up with 7,974. So I end up with f of 20 equals 7,974. All of these things are a lot easier to do by hand once you know synthetic substitution. Here's an example of this that I've already worked out to try and keep the video short. If I have some sort of function, polynomial, x cubed minus 4x plus 10, and I divide that by, for example, x plus 6, I end up getting x squared minus 6x plus 32 minus 182 over x plus 6. That part's the remainder. So if I multiplied through by x plus 6, what I would end up with is I would take this entire equation, I'd multiply through by x plus 6, and I would get x cubed minus 4x plus 10 equals the blue part, q of x, times x plus 6 plus negative 182. So that's basically what ends up happening. Then if I substitute a negative 6 in, this whole part becomes 0, and I'm just left with negative 182. So f of negative 6 would have to equal negative 182 in this problem.